Hello everyone, in this video I would like to use Rockwell Compact Logix 5370L3 L33ERM, this actual controller, and set up the Studio 5000 project, and let's set up the motion access. To set up the motion access, that is an essential step before we start to program the motion control command. For example, power on the access, home, or do the move relative or move absolute. So the common used middle level motion control, maybe the Compact Logix 5370, that is a common used level controller, especially if we integrate Kinetics 350, do some lower power motion control for the positioning control. So this level controller is very common. And this PDF, that is a Compact Logix 5370L3 profile, this PDF file, it has 2 pages. So the next page, let's scroll down. And from this product specification, so we will see if we need to do some integrated motion control. For a lower end, we can select L30 ERM. And in this video, I will use the 1769 L33 ERM S. The S means the safety integrated. But other than the safety, that is the same idea as L33 ERM, can provide 8-axis CIP motion control. The CIP means the motion, the servo drive that can communicate with this controller using the Ethernet IP. That means this controller, they can do 8-axis motion positioning loop control. For a higher end, that is a L37 or L38, this is a high end. But the common used, the motion control in the machine level system, L33 ERM is very common used. And another reason that is a common used, that's because from this software version, as we know, Rockwell, this software has a multiple versions from RSLogix 5000 till the Studio 5000, or we call RSLogix 5000 version 33. So from this version 20 to version 33, they have a different versions. And according to your software, you need to download the firmware, flash the firmware to the controller. According to the software you have, this L33 and L36, they can be widely used for different versions. For example, if you are using version 24, even if this is an old version, but your RSLogix 5000 version 24 still can work for this L33. You just need to download version 24, the firmware, to this controller. For the brand new controller, you have to download the firmware because its original firmware is 1 point something. If you purchase one brand new controller, it's waiting for you to download one new firmware according to your software. And in this video, I will use this controller and set up the Studio 5000 version 32, this version, and set up one project, and let's set up the virtual motion access. And then in the following video, in the next video, I will show how can we run the direct command to control the access. So we have a rough idea using the home access movement, how we can control the access using the direct command. Okay, let's go to the Studio 5000 side. Let's set up the project. Okay, once you open the Studio 5000, click the new project, and from this catalog, select the controller you have. Keep in mind, for motion integrated controller, they will have ERM, and my controller, that is a safety integrated, so it will have ERM as the safety integrated. So I will select this 1769 L33 ERMS and name your project and click the next. And here select the version that match your software and match your hardware. Okay, and in this case my version is 32. Click the finish. Okay, here. Firstly, let's click this property, controller properties, and let's have a quick review. For this L33 ERMS, this is a project number, and I highly recommend you can write some descriptions whatever you are testing this project or doing an actual project. Write some information according to your project, and also from this network. And also go to the capacity, so you can look at the estimated data and the logic memory, and your controller cannot cover your task and workload. Keep in mind this, the estimated data and the logic memory. and then go to the port configuration and the network. Here, that shows the actual IP address for this controller. Now, I'm going to download first and make sure my project can communicate with my actual controller. Okay, close. And before we download the controller, we need to use the RSLink to find the controller. Okay, RSLink classic. Okay, from this list, so we can find my RSLink already found this controller. Its IP address is 192.168.1.10. If this is the first time you are going to connect your controller, so you can go to your Windows and select this bootp DHCP tool. And by default, at the first time, if the controller is brand new, so the controller doesn't have any IP address, so you need to use this bootp. Using the MAC address, find that controller. Basically, we better directly P2P connect using the Ethernet cable, and then click that line you have and set the IP address after. After this, from this RSLink, you can browse that controller. And then come back, we can click this select communication path. Okay, and from this Ethernet IP, this drive, so the software found this 1.10, this controller. It will show up the download or upload or update the firmware. Now I can select this download. And if I download correctly, and if here shows online, so that means I can connect this controller correctly. And the rest of the tasks, I can download my program and use this controller. Okay, so once we download, we can click the remote run. Okay, turn on this controller and turn to the run mode. Okay, now here it shows the connection. From here, we can click this controller properties. Now we can see the internal protocol. Here it shows IP address. If you need to change your IP address, you can change here, and don't forget, download the controller. And click this network, it will show some status. Okay. And then once we shift to the offline mode, let's go to the properties again. To do the motion control, one important setting in the controller properties, sometimes people will forget that is go to the date and time. And here, that is enable time synchronization. If you are going to use the Kinetics motion drive and using the Ethernet IP between the controller to the motion drive, you need to use the CIP communication. So using the CIP motion control, you need to select this enable time synchronization. Keep in mind this and click the OK. Another important setting I prefer to set, that is the next selection. So go to the advanced. And here, that is a task priority here. Personally, I will prefer select this, reserve for the system task, especially for the communication. I will prefer to select this, reserve for the system task, for example, the communication. So this is the two important selection in the controller properties. Click OK. And once we download this controller, those settings will be enabled in the actual controller. Okay, now let's go to the motion groups here. So firstly, we need to set up one motion group. Right click, click this new motion group. Okay, firstly, this is the motion group name. So we can name it motion access group. So this scope we name under the controller, this controller tag. Okay, great. Okay, motion access group. And the individual access, we will set up the individual access under this motion group. This motion group is very important. There's a couple important settings within this motion group. Let's set up the individual access, and then we will go back. I will show the settings here. So now let's set up the virtual access. Right click, click this new access. Because the typical way for the compact Logix controller to communicate, to control the servo motor, this is using the Ethernet IP. So that's why we can set up the access CIP drive, especially if you are using the Kinetics 350 or higher end Allen Bradley servo controller. And in this case, we are using the access virtual. So using the access virtual, that is a similar idea. We will set up the virtual access using the TO technology object. using the Siemens TI Portal software. Based on this virtual access, so we can test the motion instructions, for example, hold, jog, or move, or do some speed control. We can test our logic only. We do not need to wait our actual servo hardware. You do not need to wait the motion side. Especially for the new learner, you do not need any motion hardware, so you can do this test. Let's select this virtual access. And here I can select this access 1 virtual. Okay, and here for this access, I will prefer to select this scope, the controller tag. Those controller tags are located here, controller tags. Okay, click OK. All right, we set up one virtual access. If you are having the actual motion controller, so you can click the right side, click this new access, and select this access CIP drive. For example, I will assume the controller would be 350 here, so click the OK. We can see for the virtual access, it will show the gray here. For the actual hardware, it will show the solid color here. And let's look at the difference. If I double click here, and this is the properties of this virtual access. And if I double click this is actual hardware, so we can see the difference. And the key difference between this virtual and actual, for this actual access from this associated module, so we need to select the actual hardware. To select this hardware from this Ethernet network, we need to insert the motion drive system. For example, the Kinectix motion drive. And because this is the actual hardware loop, so there will be the precision loop, velocity loop, some settings, more settings here. And to do the simple test, so we can use this virtual. And the key information, actually, they all here. Homing and the dynamic speed and some positioning mode. For example, if that is a linear move or rotary move. And the unit. And those settings in the virtual access has a similar idea as this real access. So they are the similar idea. So let's go to this group setting here. So right click, click this properties. So firstly, you can assign one single access can be a part of this motion group. So basically, you need to assign the access within this group. Because the key setting, they are here, the attributes. From here, you can assign basically the cycle time, the processing period you need to set. The smaller value, the high workload the controller will have. For example, for this 2 milliseconds, if I click this access schedule, for this 2 access with the 2 millisecond setting here, so that will cost 11.7% logic controller workload. If I set smaller, for example, if I set to 1 milliseconds, so we can see task IO cycle, that basically takes 50% the workload, and the logic controller can take 33%. This is really heavy workload. 2 seconds, that is the default. I saw some motion projects, people will use this default. That makes sense. But sometimes we can see if you set up multiple access, for example, if you are using 4 access or even 5 access, actually at that time, the logic controller is really heavy workload. So keep in mind, if you positioning control, you do not need that high dynamic performance. Probably you can select a higher this milliseconds value so that it can cause a lower workload for your controller. And keep in mind this alternative setting, so we can select others. Okay, so keep in mind this group setting here. And in this case, because I'm using the virtual access, I can leave this 2 milliseconds as a default here. This attributes for this motion group is very important. Okay, and then let's go deep into this virtual access. Double click. So firstly, we can see because this single access belongs to this group, so it will show the 2 milliseconds, this update period. Okay, so if you click here, it actually jump into this group setting here. And then let's go to the motion planner here. So this, sometimes we need to select the program stop action. So from this job list, we can select the fast stop or the hard disable or the hard shutdown. So most of the cases we'll select this fast stop. Basically, we will leave this default, but if your system has a special requirements, even if you are using the actual hardware, keep in mind, you probably need to reselect this. Sometimes we need to quickly shut down or disable the drive. In actual cases, probably we could select this, enable the master positioning filter. For the virtual access test, it will be fine, but in actual cases, probably we need to enable this filter. And then let's go to the units. That will allow your test to make sense. For example, if you are using the linear access, so probably this unit would be the millimeter. If you are controlling one rotary, for example, you need to verify 3 revolutions, probably you need to use the revolution or use the degree. In this test, I will select a millimeter. I will assume I'm using the linear axis. Okay. Let's go to the conversion. So here, the positioning mode, this is I just said. So for the linear control or for the rotary control, you can select the motion tab. So in this case, I will select this linear. And according to this conversional constant, this value, this is conversional amplifier. If we go to the help, we can look at the detailed description for this. So this conversion constant that's explained here. For testing purpose, this value could be leave as a default, or some cases, I will select the 1000, make this conversional 1/1000, okay, this ratio. And then let's go to the homing. For the new learner, we need to separate the one idea, home and a 0 position. So this is the 2 different ideas. Home basically associate with your actual application. For example, the initial position of your access, or basically your mechanical system stay here as a perch position. So that position we will select as a home position. Therefore, if this is a perch position or this is initial position, that value would be 800 or 1000. So this 800 or 1000 will be the home position value. So once we trigger set home, that value will directly set to the axis, will change our axis position value. For testing purpose, most of the cases we will set 0. So once we execute set home, so our axis will directly override to 0 value. And keep in mind, we are using the active, so that means once we active this home, so it directly write this 0 value to our axis, directly 0 our axis. Okay, this is active mode. And to check this home mode, we can select this help. Home, the axis would be a multiple choice. And to better understand the homing process, probably you can search this Logix 5000 motion modules. We need to find the homing process. This manual provides more detailed information. So this manual has 559 pages. It has a lot of information. And here, from this chapter 13, so we can find the detailed explanation for the active homing and the passive homing. For example, for the active homing, this I would like to explain. Probably when you active the homing, so your axis will be somewhere, but this is the actual home position. So to find out the home position, there will be a process allows the axis, allows your motion to find the actual home position. So to find out this home, we have a different ways. For example, for this is active. That is a bidirectional home with a switch. And also we have a multiple scenarios. For example, let's scroll down. And this probably an easier scenario. So this with marker. Marker is actually more accurate than marker that is within the encoder. So like this case. So there will be a multiple scenarios. I highly recommend you read the detail for this homing. If you didn't home the axis correctly or accurately, so all the positioning control after will not be accurate enough. That would cause a problem. So keep in mind, home is very important. And in this test, I will assume my home position, that is the actual 0 position. Okay, this is the active mode. And let's look at the dynamic. Here, that's also important. That is some default value stored inside this axis, inside this TO. For example, the maximum speed and the maximum acceleration. That's basically give you a zone, give you a limitation to protect your hardware or protect the mechanical. So in this case, I will set the speed is 500 and acceleration, we can set the 2000, for example. And the maximum deceleration, we can set the same. And the maximum acceleration jerk, so this is a jerk, so we can set, for example, 5000. Okay, here. Also, you can click this calculate, so it can calculate based on your performance. Okay. And I will set this as a default. And the tag, that is the actual tag name within this controller tags. Okay, till here, we click this apply and click OK. So we set the basic setting in this virtual access. So the tags that locates within this controller tags. If we open and all the key information, for example, the actual position value, speed, velocity, they locate here. For example, the fault and the status value. And if we scroll down, especially for the motion control, we really care about the actual position and the velocity. Some cases we need to use the average velocity to check if the axis is within the standstill status. This average velocity would be also an important value we need to monitor. So we can see all the key values we can find from this axis. Okay, now we finish the setting and we can download to the controller. And after this, we can right-click, click this motion direct command. This motion direct command is very common used tool to test the system, especially the first time we set up the mechanical system and try to test the mechanical system and the drive system. For example, we need to verify the drive direction, if that forward is the actual forward direction. Also, we need to verify if the speed setting, for example, 300 millimeter per second, if the actual object can run this velocity. So this is very common used tool to verify our hardware and our entire control system. In next video, I will discuss this, how to use this direct command. See you in next video. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.